Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to continue our discussion about multiplying polynomials, but we're going to talk about some special cases of multiplication. And again, you could probably do all the problems in this lesson based off of what you know. You may just learn some shortcuts today. And we'll also talk about how to not make some common mistakes that students may make when working with these types of problems. Okay, let's look at this problem right here. It says, below is Carmen's attempt to square the binomial. Decide whether Carmen is correct. If she is not, state what mistake she made and show your work for a correct answer. All right, pause the video, take a minute or two, and see if you can find a mistake. And if so, maybe correct it and write what the correct answer should be. Maybe there's no mistake and you're just checking to make sure Carmen's work is correct. Okay, so it looks like Carmen decided to distribute this exponent to the 5 and the x. And this actually isn't how exponents work, right? What this exponent is telling us is that we need to multiply this quantity x plus 5 by itself 2 times. Right, so that's what the quantity x plus 5 squared really indicates. And if we go through and do this distributing, well, I get x squared plus 5x. Then I have 2 more to do. I have plus 5x again, and I have plus 25. If I go ahead and combine my like terms, I'm going to get x squared plus 10x plus 25. So this is the correct answer here. Carmen just used an incorrect rule of exponents, again, which is a common mistake here. When we see this binomial squared, when we see any binomial squared, students have a tendency to just square both of the inside terms, the x and the 5, to get x squared plus 25, or whatever the terms are, right? They could be m's, they could be n's, they could be 8s, -8s, etc. But we have to remember that exponents mean we have to multiply that binomial by itself twice. Okay, let's go down here to the second page. And we kind of already talked about the number one mistake. But the number one mistake students make when squaring a binomial is incorrectly applying the rules of exponents. And we just talked about what that rule was. Right, this right here is not a true statement. The quantity a plus b squared is not equal to a squared plus b squared. It is equal to the quantity a plus b times the quantity a plus b. So go ahead and work through these 4 problems. You're just squaring some different binomials, and you may actually notice some patterns. You may notice a pattern where you may not have to actually write all of the distributing out. Maybe you'll notice a shortcut for how to get from what we start with to the final answer down here. And again, maybe you notice it, maybe you don't, but we'll discuss after you've done all 4. Okay, so our answer here should be x squared plus 8x plus 16. Our answer to the one on the right should be y squared plus 6y, not equals, plus 9. The one down here, we get x squared minus 10x plus 25. And here we get y squared minus 2y plus 1. Just making sure my variables matched. Okay, so again, you had a bunch of work in between. I just wrote down the answers. But do we think there's a shortcut to go from what we start with to what we end with? Well, if I just look at this pink example, if I square x, that's going to give me x squared. And if I square negative 5, that's going to give me positive 25, right? Negative 5 squared gives me positive 25. Now, you'll notice that this works for all of these other examples up here, right? Square x, get x squared, square 4, you get 16. Same thing for the blue example. Square y, you get y squared. Square positive 3, you get 9. And of course, same for the purple, but that's blue. Square negative 1, you get positive 1. Now, we just have to figure out, is there a pattern for the middle term as well? Well, if we take a look at the red, we have x and 4 inside the parentheses, and we get 8x. Well, if I multiply 4 times x, that gives me 4x. And then if I double it, I get 8x. So 4 times x times 2 gives me 8x. So 2 times 4 times x gives me my 8x. Let's see for the blue. 2 times 3 times y, well, that gives me 6y. Down here with the pink, 2 times negative 5 times x. That's going to give me negative 10x. And finally for the purple, I get 2 times negative 1 times y, which gives me negative 2y. So to get that middle term, you multiply the two terms inside the parentheses together, and then multiply by 2. Again, this is a pattern you may pick up on, you may not. It's okay if you didn't pick up on the pattern. It's okay if you, well, I'm not going to say if you never understand this pattern, because I think you'll probably understand it when we do future lessons and we talk about factoring. But for now, if you just know how to multiply a binomial together, right? If you know that x plus 4 quantity squared is equal to the quantity x plus 4 times the quantity x plus 4, and you can do your distributing, you'll be okay, right? You actually don't need to memorize this shortcut. But sometimes in math, we see different patterns and we think, okay, is there a more efficient process to figure out a final answer or to simplify something than what we've been doing? And this pattern is one of those things, right? It just makes our lives a little bit easier if we're able to pick up on it. So if you go to the next page, right, this just kind of walks you through the shortcut. It just shows you, how to go from what we start with to what we end with. Their work may look a little different than the way we've been doing it. They're just writing their distributing process a little bit different, but they end up getting the same thing. So take a look at that if you want. It's not mandatory that you understand the shortcut, because if you understand how to distribute, you can always get the final answer anyway, but it is something interesting to look at. Let's go ahead and look at a slightly different example. So again, we have 4 problems here. You'll notice that they're not the same as the problems before. We're not squaring a binomial anymore, but there is something similar about all 4 of these examples. So pause the video and come up with answers for all 4 of these. So multiply these out and come up with answers for all 4. And then we'll go over them and look for a pattern, etc. All right, so if we look at our red answer, we are going to get x squared minus 16. That's our final answer for red. If we look over here, we'll do purple. That's going to be y squared minus 49. Down here in brown, we're going to get 4x squared minus 81. And in orange, we're going to get 16x to the power of 4 minus 1. So all of your answers here, they're not the same, but they do seem to follow a common pattern, right? There's no middle term, right? There's no x term for red. There's no y term for purple. There's no x term for brown. And there's no x squared term for the orange. So that x term just kind of disappeared on us. And if you had done all the work, right, if you had written everything out, let's do that. We're going to get x squared plus 4x. And then if I do my other distributing, I'm going to get minus 4x minus 16. And you'll notice that these middle terms, right, plus 4x and minus 4x, they're going to simplify out to give us just x squared minus 16. So like the above examples, you can just always go through the distributing process, simplify your like terms, etc. However, if you notice that the binomials you're multiplying, if they're the same except for the sign, right, x minus 4, x plus 4, y plus 7, y minus 7, 2x plus 9, 2x minus 9, 4x squared minus 1, 4x squared plus 1. If the binomials are the same except for the sign, well, we have a shortcut where you can just multiply the two first terms together and the two last terms together to get your final answer. X times x is x squared, negative 4 times positive 4 is negative 16. And that will work in every scenario here. Now the only problem is, right, this doesn't work if our binomials do not follow this pattern, right? If I have, x minus 5 times a quantity x plus 2, right, this does not equal x squared minus 10. That is not what this equals, right? And it's because this is x minus 5 and this is x plus 2. This is not x plus 5. So we have to see the pattern here if we're going to use this shortcut. When in doubt, go through and do all of the distributing. Right? Once you become more comfortable with these shortcuts, you'll eventually start to recognize them and you won't make mistakes with them. But when you're first starting out, a lot of students just try to apply these shortcuts to every single scenario, even when the pattern isn't applicable, right? And then they just make mistakes. So you have to understand, right, the only time I can use this shortcut is when my binomials follow this pattern, where they're the same except for the sign. But that is the second little shortcut we can use when multiplying binomials. That's going to do it as far as new material goes for today. On the next page, we kind of just go through again what we just talked about. The last four answers or examples of the difference of squares. This occurs when you multiply two binomials together that are the same except for the sign. So we'll talk a little bit more about what the difference of squares represents in a future lesson. What you want to focus on, right, is this has to be true for you to use this shortcut. The two binomials have to be the same except for the sign. And this work right here just kind of shows you what's going on. All right, let's see. I think we have time for a word problem. So it says a graphic designer is developing images for icons. The square pixelated image is placed inside a border that is 2 pixels wide on all sides. If the area of the border of the image is 176 square pixels, what is the area of the image? So we are given the area of the border. We know that the area of the border is 176 square pixels, and we need to figure out what the area of the image is. This problem is actually several different steps. Feel free to pause the video if you have any idea of where to start, if you can think of any equations to write down based on the different areas they're asking you for. Go ahead and play around with those equations that you can come up with. It may not be clear where to go first, but I will give you a hint. There is a way to figure out what x equals. You can figure out a number for x, which will make it easy to figure out the area of the entire image. Okay, so I'm going to start with this. It says the area of the border is 176 square pixels. So if I can come up with an equation for the area of the border, I can set that equal to 176. All right, stay with me because this is going to be a little tricky. I'm going to break this border up into rectangles. Well, the area of that rectangle is x plus 4 times 2. X plus 4 is the length, 2 is the width. Remember, it said these borders were 2 pixels wide. So I've got 2 times the quantity x plus 4. That represents the black, shaded. Let's do purple. We have the same thing down here, right, in purple. Same size, just on the bottom. So again, plus 2 times the quantity x plus 4. Now let's figure out, let's do blue. Maybe that'll be easy to see. The area of the blue shaded region, well, that's going to be x times, again, we know that width of the border is 2, so x times 2. Same thing on the other side. I'll do that one in blue as well. Plus x times 2. I know all of that is equal to 176. So if you weren't able to come up with that equation, go ahead and simplify and then solve that now to figure out what x equals. Okay, so when I simplify, I get 2x plus 8 plus 2x plus 8. Again, I'm just distributing. Plus 2x plus 2x equals 176. If I simplify, I get 8x plus 16 is equal to 176. That gives me 8x is equal to 160. And that gives me x is equal to 20. So I know that x is equal to 20. And now I need to figure out the area of the image. So this area that I'm shading in orange right now. Well, the area of the image is just x times x, right? We can see that from the diagram. So area of the image is equal to x times x. That's going to be equal to 20 squared, or 20 times 20. That's going to be equal to 400 square pixels. So a couple different steps here, but we're just setting up equations for areas of rectangles, adding them together, and then doing some simplifying and solving. That's going to do it for this video, guys. We're just short of 20 minutes, so we're going to stop it here. Enjoy the rest of your day, and I look forward to seeing you next time.